Hi, I made this project for my college algebra class. This has to do with parabolas and conic sections, and I wanted to link it to my other interest, which is audio and recording. So let's go ahead and just get right into it. This is the formula that you would use to, I think this is a standard form for a parabola. When you use this formula, when you graph it, it looks something like this. Now, something very important to note here, in the middle, toward the middle of the drawing, there's a dot there labeled the focus. I want you to keep note of that because that's going to be very important later. Now, what's interesting about parabolas, or what I find particularly interesting about parabolas, is that even when you have parabolas graphed on a graph that may look different, they really aren't. They actually are similar in the same way that circles are similar. All circles, if you were to scale them up and down, will have the same dimensions. Parabolas are the same exact way. If you scale a parabola up or down, it'll have the same dimensions. This is interesting because making this project a perfect parabola is very integral to the success of the project. Now, that'll make sense in a moment. For my own reference, I found a YouTube video where a guy explained this concept really well. I'll go ahead and reference it here.
The notion of there being more than one parabola is a lie. There is only one true parabola. Behold, there is only one true parabola.
That video is fantastic. It's a really good video. I recommend you go check it out. I will place a link in the description if you want to see it. It's really entertaining. That guy has a lot of energy. I'm sure you might even be able to find some other math concepts if you need help with math. Now, moving on to the actual project itself. So, you can see here, the idea with the parabola and relating this to audio is that anywhere along this parabola, as you can see based on this image, anywhere that sound hits this surface here along the parabola, it reflects towards the focus. So this concept is used for building all kinds of stuff. The same idea relates to light. It relates to all kinds of stuff. That's why parabolic satellite dishes are shaped the way they are as well. So I'm applying this to audio. So I built a parabolic shield of sorts. So anywhere along this shield, anywhere that sound hits the shield, it'll bounce towards the focus. So the idea is that I placed a microphone, the diaphragm of this microphone, directly at the focus so that everywhere, all those sounds that reflect off of those walls will go directly towards the focus, and it'll amplify it, and it'll basically remove all of the ambient noise in the room, make it louder, all these hypotheses that I wanted to experiment with. So the way I built this parabolic shield is pretty simple. I won't belabor this point too long because it's kind of not that interesting. But I took a couple pieces of cardboard and I used this technique that I found on YouTube. I will link this video in the description as well if you want to check that out, where I used a carpenter square, a yardstick, a couple of C-clamps, and placed, for me, I didn't nail into a surface because I didn't have a workbench or a piece of wood to nail something into. So I just took a screw and I flipped it upside down and I placed the bottom end of it through the hole. I hope that makes sense. You can kind of see it in the video. You kind of have to improvise a little bit. But I used this technique using the carpenter square to draw out the parabola onto the cardboard. I had 2 pieces of cardboard layered, 2 sheets of cardboard, and then I took a razor blade and I cut the parabolic shape into both pieces of cardboard. So from there, the idea is to slide some sort of hard but solid but flexible wall into there so that I can have it be in the shape of a parabola. So I used plexiglass. I went to Lowe's. It was about, I don't know, I think it was somewhere around $20 for 2 sheets of plexiglass, about that size. I didn't end up using the second one, so If you had just one, it would be even cheaper. But I got this plexiglass. It's solid enough that sound will reflect off of it, but it's also flexible, so I can place it inside the cardboard. So I place it in there, and I just use duct tape to keep it solid. You can see from this this surface. Now, I marked where the focus was, and I have string hanging through that hole. That'll make sense in a little bit. I'll explain that. So now to talk about, I'll go ahead and go over all of the different things I use for this experiment. So I used my interface, which I'm actually using right now to record this voiceover. My Focusrite Scarlett 2i2 has 2 inputs, so I can plug 2 microphones into it. My microphones are the Samson CO2s. They're a matched pair of condenser microphones, so they come in pairs. They're identical in theory. They should be. You can see from this angle, I have the gain for both microphones at about 12 o'clock, as close as I could get, so that I can remove that variable. So from here, you can kind of see the angle that I place the microphones at. I have the first microphone in the shield itself, and the second microphone as a sort of control. I placed it closer to the sound source. Now, the sound source I used was my crate. I have a metronome that I can use to play a reference frequency. It sounds like this by itself. I used that. I plugged it into my amplifier using a cord so that it would be a consistent tone. I could use that for the experiment. I have that, as you can see here, I have it facing towards the parabolic shield, and it's just, it's emitting a consistent tone, so it should be pretty reliable. Now, moving on to the actual experiment itself. So, right here, you can see the string. The first thing I'll note is the string. I use that as a reference point for the focus. It's hanging down in that hole where the focus, that I used to measure the focus itself. So I can use that as a reference point to find in the air, in that space, where that focus is supposed to be. So I use that to find it initially. From there, I want you to note one big thing that I noticed here. The microphone inside of the parabolic shield, with the tone playing at the focus, is much more consistent in amplitude. If you look at the meters on the right, it's much more consistent in amplitude than the control that's out in the middle of the room. This is interesting because that suggests that it's actually receiving a consistent amplitude in that signal. So I believe that means that all of that sound is reflecting off of the shield, and it's hitting the diaphragm of the microphone loud enough. It's almost like I put the microphone directly in front of the amplifier. It's so consistent. Because the one in the middle of the room is picking up all kinds of sounds. It's picking up the sounds of me walking around. It's picking up the sounds of the ceiling fan. It's picking up all kinds of sounds, probably even the sounds from the next room over. It's very sensitive. It's a condenser microphone, so it's pretty sensitive. So that's an interesting thing to note first and foremost. So, and you might even be able to use this as a tool to clean up audio. Now, the next important thing to note is when I move it here, that the amplitude, the microphone within the shield, when I move it away from the focus, it is significantly quieter. It's moving it just a little bit. You can see it I didn't move it hardly at all, maybe a few inches, and it drops almost by half in decibel. It's just nuts, like a 4 decibel drop. Pretty significant, pretty notable. And you can tell even by the way that it sounds a lot less clear. It sounds further away, and that's really interesting. So I suppose that right there shows that this actually works, that this idea works, and that shows the idea behind it. But next, I'd like to pose another interesting hypothesis, is that everything in the shield, you'll notice that everything behind the shield, you can't hear as well with the microphone that's within the shield. So it's a lot more clear in there. The sound that is directed towards the shield is captured pretty clearly. Everything else behind it is absolutely inaudible. You might be able to hear, if you paid really close attention, you really surgically searched through this audio file, you might be able to find some other sounds from the room in that recording, but they're a lot less noticeable. So this actually seems like it might be a useful tool. For example, acoustic instruments that might be very useful. You might be able to use this shield if you had, say, an acoustic guitar, to capture the sound coming through that hole and capture it more clearly going into that shield, instead of capturing the nasty sounds of the room. Because my room is not particularly good sounding. I haven't treated it. I haven't done anything with it. I plan on doing some more experiments with this in the future and actually recording them and showing them, or not necessarily showing them in video form, but, you know, showing them to my peers. But yeah, that's kind of the point of this experiment. So I hope that this was enlightening, this was interesting in some respect, and you know, have a good one.